This is a video of the pre-calculus vectors unit test review. Okay, to start, draw this vector graphically and find component form. All right, so if a vector runs, or the stream runs northeast, that has a reference angle of 45 degrees. So the components would be 15 cosine 45, 15 sine 45. In your calculator, make sure you are in degree mode. Press mode. This one's in radians. Hit enter on degree. And our components are 10.606, comma 10.606. This formula of the x and the y component is not on the formula sheet provided to you. Okay, find the magnitude and direction. Now, magnitude is provided, that's this equation right here. So the vector has the magnitude of, so that's the lines like this, 9 squared plus negative 2 squared. I'm going to leave this exact as the square root of 85. Direction, we've got tangent inverse of y over x. This is just going to give us the reference angle. Of 12.529 degrees. So the quadrant to the right 9 down 2, this vector is in quadrant 4. So that means the actual angle of direction is initial ray going this way. So the angle is 360 minus 12.529. For 347.471 degrees. All right, let's do that again. But now I have to first find the component form for vector AB. That's always terminal point minus initial point. So that would be the vector 5, 7. Now we've got magnitude. I'm going to leave the value exact. That's the square root of 74. 5, 7 as a vector for when I do my direction is in quadrant 1. So the value we get from tangent inverse will be the actual direction vector. Sorry, direction of the vector. Oops. 54.462 degrees. All right, so now part B, terminal minus initial. That gets me 11, negative 5. The magnitude or the length. The square root of 146. And now the vector is in quadrant 4 again. So my reference angle I get from the tangent. $24.444. This 9 rounds that 3 up. All right, so our actual direction in quadrant 4 is 360 minus that. Three hundred 335.556 degrees. All right, find the components of the vector. Southeast direction. The reference angle is 45. So that means the angle of rotation is 360 minus 45. And our components will be magnitude cosine the angle, magnitude sine of the angle. -1.414, -1.414. Direction 35 degrees north of west. So that's this reference angle. So our angle of rotation is here. It's going to be 180 minus 35. We've got magnitude cosine, magnitude sine. All right, so for rounding purposes, this 6 rounds the 9 to a 0. So our answer is going to be negative 19.6665, 0 and 13.766. All right, for number 5. Sketch it graphically, find the component form again. All right, stream runs 25 degrees in the northeast direction. So the reference angle is 25. We've got magnitude cosine 25, magnitude sine 25. I'm going to draw both and then I'll go to the calculator. The wind is blowing towards the south. So towards the south is this, this way. So the angle of rotation is 270 degrees. All right, so for this problem, $21.751 and 10.143. For B, actually, I'm not going to use my calculator. I remember that the cosine of 270 is 0. So this will be 0. And the sine of 270 is -1. So this is -25. You can absolutely type that in your calculator. and it would give you the same thing. All right, more component form, magnitude, and direction. 9 minus 2, 7 minus -4 is not 12. So that's quadrant 1, that's nice. So the magnitude, square root of 7 squared plus 11 squared. Again, I'm going to leave my answer exact. And then direction, because this is in quadrant 1, the tangent inverse will give me the actual rotation angle. And then from here, I'll do that again for part B. There's more negatives this time. All right, that's -8, -12. Oh, this one, this is our first quadrant 3 angle. So -8 left, -12 down. Well, let's first do the magnitude. 8 squared plus 12 squared. Okay, so in the calculator, tangent inverse will give me the reference angle. (56.310 degrees. So in quadrant 3, our actual direction is 180 plus the reference angle. That gives us 236.310 degrees. All right, looks like the next one's a word problem. Nope, got to start at the top. Find the angle between. Okay, so if I go back to our formula sheet, angle between is here. But there's a few parts to it that we have to figure out. Okay, so I and J are not my favorite forms of vectors. I'm going to switch that. I is the X component, J is the Y component. All right, I like that better. So angle between, we have dot product in the numerator. The dot product is multiply the X's, add, is it add? Here's dot product. Okay, yes, it's adding. I should have screenshotted that with this. Multiply, add the Y's, and this dot product is 0. Then I need the magnitude. So U is going to be 2 squared plus 2 squared. 4 plus 4 is 8. V is going to be 3 squared plus 3 squared. 9 plus 9 is 18. So our angle between, in the calculator, we're going to type cosine inverse of 0 divided by √8 times √18. I'm going to take a shortcut here inside because 0 divided by anything is 0. So the cosine inverse of 0 is 90 degrees. That means U and V are perpendicular to each other because they intersect at 90 degrees. All right, let's do that again with number 8. Okay, dot product 5 times -6 plus 2 times -1. Now I need the magnitude. 5 squared plus 2 squared. Magnitude of V. 6 squared plus 1 squared. All right, so our angle between is cosine inverse. Dot product divided by magnitude. If you are going to type this all in your calculator at one time, you have to group the denominator with extra parentheses. I usually prefer to type the fraction in pieces and then input that into the cosine, but if you want to do it all in one, this would be how it has to be typed. So the angle between is 167.661 degrees. All right. Now we got some word problems. Let's draw a picture. I'm actually going to draw 2 pictures. I'm going to draw the plane and I'm going to draw the wind. And this is problem above. All right, so the plane flies due west at 250 kilometers per hour. The wind blows south, has a magnitude of 70. All right, so find the resultant vector if I add these together. So I'm going to do the plane plus the wind. So plane plus wind. I'm going to add these. And 3 decimal places. I'm actually not using the calculator yet. I know that cosine of 180 is -1. So this is -250. Sine of 180 is 0. So this is 0. Plus cosine of 270 is 0. Sine of 270 is -70. This is faster than typing it in the calculator. You could actually type it and have no problem, and you would get -250, -70. All right, find the distance. So that's the magnitude. The square root of x squared plus y squared. I dropped the negatives because a negative squared is positive anyway. So it's just easier to type this without the negatives. We get 259.615 kilometers. All right, the direction. So -250, -70 is in quadrant 3. So my tangent inverse is going to give me a reference angle of 15.642. But since we're in quadrant 3, we're going to add that to 180. So our direction is 195.642 degrees. All right, another one. More planes. All right. This time it's a plane that changes direction. I'll just call them both planes. All right. Plane flies east to start at 200, then 60 degrees south of east, which means this angle is 300, so 360 minus 60, and a length of 80. Label the plane angle and standard position. Oh, I just did that. Huh. Okay, well, let's explain it more. In quadrant 4, we've got 360 minus the reference angle they give us, because this was 60 degrees. That's how I got 300. Find the results in vector. All right, let's start part C here. This vector has an angle of 0. So it's 200 cosine 0, 200 sine 0. We're going to add that to magnitude cosine 300, magnitude sine 300. And again, I'm going to take a shortcut. Cosine of 0 is 1. So this component is 200. Sine of 0 is 0, so this component is 0. It's just left for me to type in my calculator. All right, so we got 200 plus 80 cosine 300, 0 plus 80 sine 300. All right, so our result is 240, comma, negative 69.282. Distance is magnitude. Let's go 800 kilometers, I think. Kilometers. All right. What quadrant are we in? 240. So quadrant 4. So our direction is going to be 360 minus the reference angle. And the reference angle is $360 minus that. All right, reference angle. So the direction is 343.898 degrees. All right, one more. 1/4 of 100 units acts on an object. Doesn't tell me the direction. I'm going to pick 0 degrees because that's easiest. Another force of 80 units acts on an object at 40 degrees from the first. Oh, I'm really glad I chose 0 now because 40 would be my reference angle with the other force. Okay, the result. 100 cosine 0, 100 sine 0, plus 80 cosine 40, 80 sine 40. Again, to help my typing, this is 100, this is 0. If you want to type the whole thing, no problem. You can do that. All right, so our resulting vector is 161.284, 51.423. Magnitude. $169.283 units. Quadrant 1 vector, so my angle comes directly from my tangent typing. And we get, can't see my numbers. $17.684 degrees. Okay, that is the end of the test review. Make sure you can do every problem independently by yourself, confidently, and don't forget about the different review warm-ups from the review days as well for your studying.